Hi guys, welcome back to SK Educates, and in today's video I'm going to be teaching you everything you need to know on how to differentiate. I'll be covering the power rule, the product rule, the quotient rule and the chain rule. In the description box below I'll put in timestamps for when I cover each topic, so please feel free to use them to go to the section that you may need help on. Otherwise the whole video is really beneficial for learning and or revision. So let's get started. Let's say we had a cubic function y equals x cubed. Now if I want to differentiate y with respect to x, which is what dy over dx means, all you have to do is look at the power, bring it down, so I want to get 3x, and then take 1 away from the power. So 3 minus 1 is 2. Another example, if I were to have a function, let's say y equal to 2x to the power of 4. Again, if I want to work out the differential, dy over dx, all I would have to do is look at the power, bring it down, so I have to multiply it by 2. 2 times 4 is 8, x, and then take 1 away from the power. So 4 minus 1 is 3. Often in textbooks they'll show you this general form, which I agree can look very confusing if you've never differentiated before, but hopefully because I've shown you examples first, this will make more sense. It will say something along the lines of, if you have a function y equal to a, where a is your some number, x to the power of n, then when you differentiate y with respect to x, you will have na, which is just the power times the number in front of x, and then x to the power of n minus 1, because we take 1 away from the power. This is exactly what you've been doing before, but they just put everything in terms of letters. I'm going to go through a couple more examples using this exact same principle, but with negative numbers and fractions, because I can understand how you can get a little bit confused, but it's honestly exactly the same. So if I had a function y equal to, let's say, x to the power of minus 3, don't be put off by the negative sign. You use the exact same principle. So when you differentiate y with respect to x, like before, you bring the power down, so I'm going to have minus 3x, and then you do the power minus 1. So minus 3 minus 1 gives you minus 4. Another example, if I were to have y equals x to the power of 3 over 2. Again, don't be put off by the fraction. When you differentiate y with respect to x, as always, you bring the power down, so I'm going to have 3 over 2x, and then take 1 away from the power. 3 over 2 is 1.5. If I take away 1, I get a half. Again, you're using the exact same power rule that we've been using before. Just a couple more examples. If I were to have y equals x, for example. If I want to now differentiate y with respect to x, remember, if there's no power there, it's just a 1. So bring the 1 down, so we have 1x, and then take 1 from the power. So 1 minus 1 is 0. But we know that any number to the power of 0 just gives you 1. So this is the same as saying 1 multiplied by 1, which is just 1. So if I had y equals 2x, the differential becomes, remember if there's no power there, it's a 1. So I do 2 multiplied by 1, which is 2. X to the power of 1 minus 1 is 0. And we know this is just equal to 1. So 2 times 1 is just 2. Now hopefully you'll realise that if you just have a function, which is any constant, which is just any number, which is a, multiplied by x, when you differentiate, it's just going to be the constant, which is a number in front of x. So these are just a few cases that I've shown you to make sure everything is clear. Now let's put it all together. So let's say we had a more complicated function. It just has more terms. Y equals 4x cubed plus 2x squared plus x to the power of 3 over 2 plus x to the power of minus 4. Now, if you want to differentiate this function, don't be thrown off. You just do each of these terms separately as we've been doing before. So now, if I differentiate y with respect to x, our first term becomes, again, do this multiplied by this, so 4 times 3 is 12, x, take 1 from the power, 3 minus 1 is 2, plus, again, bring the power down, so I want to do 2 times 2, which is 4, x, and then take 1 from the power, so 2 minus 1 is just 1, so I don't need to write it there. Plus, bring the power down, I have 3 over 2, x to the power of 3 over 2 minus 1 is just a half. And finally, bring the power down and I'll have minus 4x, and take 1 away from the power, minus 4 minus 1 is minus 5. And this is your final answer. And this is the basis of differentiation. As you can see, it's a lot easier than people make it out to be. So now let's move on to the product rule. Now that I've taught you the power rule, we're going to implement this and learn the product rule, which is when we're faced with the product or the multiplication of two functions, which in this example, we have x cubed plus 2 multiplied by x squared plus x plus 1. Now for simplicity, I'm going to call the first function u and its derivative u dash. For the second function, I'm going to call it v, and for simplicity, the derivative v dash. Therefore, u is just the first function, which is x cubed plus 2, and u dash is its derivative, which is 3x squared. Remember, if I differentiate 2, I just get 0 because it has no x term. Remember, if I differentiate 2, it just becomes 0 because it's just a number. And then v is equal to x squared plus x plus 1. So v dash, which is just its derivative, is going to be 2x plus 1 and then plus 0. So the product rule in general terms is if we have y, which is a function of u and v, where both of these are functions of x, dy over dx will equal the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. And don't worry if you're confused right now. When I show you with the example, it will become a lot clearer. So this is the general form in terms of u and v. So now let's put it into practice. So all I've said with that general form is I'm going to take this function and multiply it by the derivative of this function, plus this function multiplied by the derivative of this function. Now let's put it into practice. So the differential of this function as a whole, dy over dx, will equal to the first function multiplied by the second derivative. So x cubed plus 2 times by v dash, which is 2x plus 1, plus the second function multiplied by the derivative of the first function. So the second function is just x squared plus x plus 1, and then the differential of the first function is just 3x squared. Then you can expand these and simplify, so let's do that. If I expand these, I'm going to get 2x to the power of 4 plus x cubed plus 4x plus 2. I'm just expanding the brackets. And here we'll have 3x to the power of 4 plus 3x cubed plus 3x squared. And now we can simplify this by collecting like terms. So what I'm going to be doing is doing 2x to the power of 4 plus 3x to the power of 4, which is 5x to the power of 4. And then x cubed plus 3x cubed is plus 4x cubed. This is just simplification. And then plus 3x squared from here, which can't be simplified any further, plus 4x, which again can't be simplified any further, and then plus the 2. And this is your final answer. It is actually not difficult. It may look a little bit complicated, but all you're doing is taking the first function, which we have here, and then multiplying it by the derivative of the second function, which we have here, and then taking the second function and multiplying by the derivative of the first function. Now let's move on to the quotient rule. Now that we've completed the product rule, what would happen if we had the same two functions but divided by each other? Because I'm using the exact same functions, I'm going to use the UU dash VV dash and place it here. So these are just the two functions divided by each other, and these are itself and its differentials. So let's go straight onto the formula. So now y is equal to u over v, where u and v are both functions of x. So the differential of y with respect to x is u dash v minus v dash u all over v squared. This means the top differentiated multiplied by the bottom minus the bottom differentiated multiplied by the top all over the bottom squared. I know it might seem a bit complicated, but if you remember the formula, once you've done this, all you have to do is substitute. So, in place of u dash v, I'm going to put 3x squared. So the top differentiated is 3x squared multiplied by the bottom, which is x squared plus x plus 1 minus the bottom differentiated, which is 2x plus 1, multiplied by the top, which is just x cubed plus 2, all over the bottom squared, which in this case is x squared plus x plus 1 squared. Then you can expand like we did before and simplify. Now that we've also completed the quotient rule, the final rule we're going to go over is the chain rule. Now let's suppose we have a function y equal to 4x plus 3 all squared. Now at this point, if you've never learned the chain rule before, it's very likely that you would expand this and get 16x squared plus 24x plus 9. And then you would proceed to differentiate this function, which is completely correct. But what would you do if I gave you the same function, but to the power of 8? It will take way too long to expand it 8 times, simplify it, and then differentiate. That's where the chain rule comes in. It is a lot quicker and actually very easy. So, if I now want to differentiate y with respect to x, your first step, very similar to the power rule, is to look at your power, bring it down. So I'm going to have 8, and whatever's in the brackets, and then take 1 from the power like we did before. So 8 minus 1 is 7. So essentially, you're treating all of this as just an x term. So you just take the power down and take 1 from the power. But the additional step that you can't forget is to multiply this by the differential of the inside. So, if I differentiate 4x plus 3, I just get 4. And this is your final answer. You can proceed to simplify. So 8 times 4 is 32. And then you have your 4x plus 3 all to the power of 7. And that's your final answer. That is just how easy it is. I'm going to go through a couple more examples because this rule is very important. So if we were to have, let's say, y equals 2x squared plus 4x plus 1 all to the power of 10. Again, you're not going to expand this 10 times, it will take too long. So to differentiate y with respect to x, all you have to do is bring the power in front like you've done before. So bring it down. So I'd get 10. Then keep the same bracket. And take 1 from the power. So 10 minus 1 is 9. So you're essentially treating all of this as just one x term. But then your final step to account for this is to differentiate the inside of that. So I would get 4x plus 4. And then simplify, so I'd have 10, 4x plus 4, and then 2x squared plus 4x plus 1 all to the power of 9. And that's your final answer. We have now completed all the rules. I do recommend you try questions. I think it's really important.